Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Rusida Wirunisa. My attendance student number 17. I'm from C class of Electrical System Engineering. And now I will fulfill the final semester assignment from the Electrical Power System Instrumentation course. It's supporting lecturer Mr. Irwan Herianto, STMT, or Mr. Eric. Okay, I will immediately present about 150 kilovolt tower equipment and accessories for tension type BBCCDD with 2 circuit lines. There are 4 table of contents today of this presentation. First is introduction, fundamental concept of electrical power transmission, types of tower transmission. The last is tower equipment and accessories of SUTT or SUTA transmission system. Okay, number one is introduction. Okay, introduction is about in an electrical power system. Electrical energy generated from power station is transmitted to load control centers through a transmission line. The transmission line can be in the form of air ducts or underground tracks, but generally in the form of air ducts. Electric energy that is channeled through the air transmission line generally use bare wire so that it relies on air as the insulating medium between the lead wire and surrounding objects, and to support or stretch the lead wire with a height and distance that is safe for humans and the surrounding environment. Lead wire it is installed in a sturdy building construction, commonly called a tower. So between the tower or electricity tower and the lead wire is insulated by an insulator. So a tower or electric tower must be strong against the load acting on it, including tower rig and conductor wire or compressive force and tensile force due to stretching of wire, and third, wind force due to wind exposure on the wire or tower body. Second content is fundamental concept. There are 3 fundamental concepts generally. Number 1 is voltage. The voltage of a transmission line determines the line's ability to transmit electricity. Usually, the electric force or electric potential is measured in volts or in short is V. And number 2 is current. The current through transmission line is a measure of the amount of electricity that is moving through a conductor, and usually is measured in ampere. Number 3 is power. Power flowing through a power station is measured in watts or W, or more typically megawatts or MW. Types of tower transmission. There are 2 bases of transmission tower type, based on function and based on shape. Transmission tower type based on function. According to different consideration, there are different types of transmission towers. The transmission line goes as per available corridors. Due to unavailability of shorter distance, the corridor transmission line has to deviate from its straight way when obstruction comes. So according to the angle of deviation, there are 4 types of transmission tower. And beside of this table, the type of tower based on function. Example, type tower AA, function for suspension and deviation. In the deviation, 0 degrees until 3 degrees. And there is a major types of transmission towers. Number first is tension tower. Tension tower, besides holding the gravity, the function to receive tensile force due to change in the direction of the high voltage or SUDT or extra high or SUDT air channels. And their tension pole consists of angel tower and dead end tower. Angel tower is receive tensile force due to change in the direction SUDT or SUDET air channels, and dead end tower. Dead end tower are tension tower which are planed so that they are strong enough to resist the tensile force of conductor from the direction only. And this is a picture of angel tower. We can actually see in the middle of uh, field. Maybe there is a angel tower, or maybe in the side of road. So okay, next is suspension tower and section tower. Suspension tower to support and must be strong against the gravity of the electrical equipment that is on the pole. And section tower, namely the section tower between a number of buffer towers with a number of other buffer towers for reason of ease of construction. Or conductor withdrawal generally has a small turning angle. Transposition tower is a tension pole that serves as a place to move the arrangement of the pieces of the conductor of SUTT or SUTT air conducts. And in the right side, there is a picture for transposition tower. Gantry tower, portal-shaped tower is used for the crossing between two transmission lines, which requires lower altitude for some reason. Example, airport or maybe crossing pool. And this pool is built under the existing transmission line. This we can see the picture, the right side. And then combined tower. Combined tower is very familiar for us because we usually see this tower, namely the tower used by two transmission lines with different operating voltage. So in this tower, there are two transmission lines across this tower. And then transmission tower based on shape. First is pole tower. Pole tower consists of steel pole and concrete pole. And this is the picture of steel pole and concrete pole. Before that, SUTT construction with concrete or steel poles, it's used in the expansion of SUTT in a densely populated city and requires relatively narrow land. And then lattice tower. Lattice tower is made of profile steel arranged so that it is a tower that has calculated its strength according to its needs. So based on the arrangement or configuration, the delivery is divided into three large groups, namely Delta Tower, Zigzag Tower, and Pyramid Tower. Okay, next is tower equipment. The last content of this presentation is about tower equipment and accessories of SUTT or SUTET transmission system. Okay, based on the function of each component, the SUTT or SUTET transmission system is classified as follow: current carrying, insulation, structure, and junction. Current carrying, the components include SUTT or SUTET components that function in the process of channeling electric current from the generator to the GI or GITET, or from the GI or GITET to the other GI or GETET. And the insulation, for insulation, the structure, the main component of the structural function in the SUTT or SUTET transmission system is the pole, or we can say tower. And the last is junction, functioning to connect the current carrying subsystem, the insulation subsystem, and the subsystem structure. First is current carrying. The conductor material used for electrical energy lines needs to have the following properties. There are high conductivity, high mechanical tensile strength, low specific gravity, economical, flexible, or not easily broken. Because in this current carrying, we can talk about conductors. Okay, next is type of conductor based on the material. Number one is Cooper type conductor, or BC. It's usually we can say bare copper. The conductor is a good conductor because it has high conductivity and good mechanical strength. And then there is a aluminum type conductor. Conductor with aluminum material are lighter than copper type conductors because maybe the color. And then their conductivity and mechanical strength are lower. So the conductivity and mechanical strength of aluminum type conductor is lower than copper type conductor. So this is there is an aluminum type conductor. The first is ACSR conductor, or aluminum conductor steel reinforced. This type of conductor, the inside is steel which has high mechanical strength, while the outside is aluminum which has high conductivity. So inside of this conductor, there is a steel which has high mechanical strength, and the outside of this conductor has aluminum which has high conductivity. And number two is TACSR conductor, or thermal aluminum conductor steel reinforced. In the transmission line which has a high capacity of channel distribution or load, TACSR type conductor are installed. This type of conductor has a larger capacity, but the weight of the conductor does not change much. So, but affect the sagging. So this conductor have a large capacity, and the weight conductor is not changed much, but affect the sagging. Number three is ACCC type conductor. This type of conductor, the interior is in the form of a composite that has high mechanical strength because it is not from conductive material. Then this material does not experience expansion when burned with current or voltage. Okay, next classification is insulation. Insulation serves to isolate the part that is in tension with the non-voltage part, but during normal continuous operation and during the surge, including lightning, inside the transmission line. And according to its function, a good insulator must meet the properties of electrical characteristic and mechanical characteristic. Electrical characteristic: insulator has rated lightning impulse withstand voltage and working voltage, minimal breakdown voltage according to working voltage, and is an insulating material made by metal, so it's a capacitor. Its capacitance is enlarged by pollutant and the humidity of the air on its surface. If the insulation value decreases due to pollutants or damage to the insulator, insulation failure will occur, which will eventually cause interference. And mechanical characteristic: insulator must have mechanical strength to bear the tensile load of conductor as well as the heavy loads of insulator and conductors. There is a type of insulator. Number first is pin insulator. Pin insulator widely used for overhead high voltage power transmission line, and these types of insulator much popular in 30 kV distribution lines. Most of pin insulator manufactured by use of glass and porcelain material. As we can see in the right picture, there's a pin, there's a glass, glass and porcelain material. And this picture use glass material. For higher voltage of transmission line, use more numbers of pin insulator compared to low voltage transmission line. Number two is suspension insulator. Suspension insulator has a greater accessibility over other insulator types. If any insulator disc is damaged in transmission line, it is much easily replaced even the transmission line is energized. So this suspension disc insulator inside of suspension insulator is when this damage in transmission line, it's much easily to replace even the transmission line is energized. So I think it's easy and safety, although the transmission line is energized. The suspension insulator also has great capability of taking care of the tension of the conductor and the transmission line compared to other types of conductor. And then strain insulator. Strain insulator are widely used where the tension load of conductor is higher. The most important factor of strain insulator is a mechanical strength. And then the last, ground clearance around the conductor wire. Air insulators have to insulate between the live and non-voltage parts, and the electrically intercepting phase failure of air insulation function is caused by breakdown voltage exceeded, or especially improper distance, change of air resistance or over voltage. And air clearance or ground clearance has minimum clearance, that is the shortest distance between SUTT or SUTAT carrier with ground surface and other activities around it, which must not be shorter than that specified for the safety of humans and other living creatures, as well as the safety of SUTT or SUTAT operation. And then the classification, next classification is structure. Structure, I think structure is the main component of the structural function in the SUTT or SUTAT transmission system is the pole or tower. So the main component of structural function in transmission line, SUTT or SUTET, is the tower. And then the structure is divided into three parts, namely bracing tower, nuts and bolts tower, and foundation. Bracing tower secret from a tower structure that function to maintain the lead wire at a certain ground clearance distance so that the power transmission process continues. And nuts and bolts tower function to unit the bracing to form a tower construction. And the foundation is once it's constructed to pin the tower foot or stop with the earth. So the tower foundation that bears tension load is designed to be stronger or bigger than a suspension type tower. And this is a picture, example picture for nuts and bolts tower and the foundation. And then the last is junction. Junction is functioning to connect the current carrying subsystem, the installation subsystem, and the subsystem's structure. So based on its role as a supporting component, the junction is divided into A, connecting the current carrying subsystem with the insulation subsystem, who consists of a strain clamp. Strain clamp is a device that is attached to the conductor to tension insulation equipment, which serves to hold the conductor on the tower tension. And number two is teeth and compression. This component function is to as a conductor holder in the tower tension. And then socket clevis and bolt clevis. Socket clevis to connect the bolt insulator with the hot yoke on the tower tension, and bolt clevis to connect an insulator socket with a link. And then square plate and shackle. Square plate for the holder or anchor conductor in the double conductor tower suspension and tower tension, and shackle is to connect the link with the tower. And then turnbuckle or span screw and link adjuster. Turnbuckle is to regulate the tension or slack pull of the conductor or conductor. And then the link adjuster is to connect the yoke with the conductor and obtain the desired shaking. And B is linking the insulator subsystem or insulation with the subsystem structure. Number one is link pull socket and extension link. Link pull socket to connect the insulator socket with cold yoke on the tower tension. Extension link is for extension link is for connect the threads with the yoke on the cold and side tension tower. And the shackle have the same function to connect the link with the tower. And adjuster plate to regulate shaking. Insulator on tower tension. And then to connecting the insulator and terminating the insulator to the junction of the conductor and the junction of the tower consisted of ceramic or non-ceramic ball and pin insulator. And then is to connecting between the lightning safety system consisting of GSW joint. Okay, thank you. I think enough for this presentation about equipment transmission line on 150 kilovolt with two lines. If there is a wrong words or a wrong explanation, I apologize previously. I think enough. See you in the next video. So, wassalamualaikum warahmatullahi wabarakatuh.